You know, the green revolution, it's got this secret ingredient. It's not just about solar panels or giant wind turbines. Nope. It's something much, much smaller, way more powerful, and the global race to control it is seriously heating up.
Think about it. Every time you see an electric car charging or one of those massive wind turbines spinning in the breeze, you're looking at tech that is absolutely packed with incredibly strong magnets. The whole green transition, from our cars to our power grid, it all runs on magnets.
So, what happens if the supply of these critical supermagnets is suddenly at risk? What happens when the very engine driving this green future just starts to fail? And that, right there, is what we're going to dive into today. The hidden magnet problem. So, what are these things? Well, they're called rare earth permanent magnets, or REPMs for short. They're a really special class of magnet made with, you guessed it, rare earth elements. And they are absolutely essential for any high-performance motor where you need a ton of power, but you can't afford a lot of size or weight.
And when I say powerful, I mean it. The difference is just staggering. This chart here measures a magnet's power in something called BH max. You can basically think of it as the magnet's horsepower. So your old-school ferrite magnets, they're maybe a 5. Alnico magnets get you to 10. But REPMs, they start at 55 and go up from there. It's not even in the same league.
And that's the catch, right? We've become totally dependent on these world-beating magnets. But that dependence comes with some massive risks, namely a super fragile supply chain and wild price swings that threaten our ability to even get them. But when you're faced with a huge problem like this, what do? You innovate. And right now, scientists and engineers are tackling this from a few different angles, which really come down to 4 main strategies. Okay, so here are the 4 big approaches. First up, invent entirely new magnetic materials from the ground up. The second is reformulation, basically tweaking the recipes for existing magnets so they need fewer of those precious rare earths. Third, substitution, just swapping in older, weaker magnets wherever you can get away with it. And finally, the big one, redesigning things like motors so they need fewer magnets or maybe even none at all.
Right, so not all of those strategies are created equal, and this sets up a classic innovation dilemma. Do you pour your resources into the long-shot, game-changing moonshots, or do you focus on the more practical, immediate fixes?
On one side, you've got the moonshots. These are your high-risk, high-reward ideas, the kind of thing that could literally change everything, but they might be a decade away, if they ever pan out at all. And on the other side, you have the practical fixes. These are the lower-risk, near-term solutions that can start making a real impact, like today.
To really get a handle on this, experts use a scale called the Technology Readiness Level, or TRL. It's actually pretty simple. It's a scale from 1 to 9. A TRL of 1 means it's just a basic idea someone cooked up in a lab. A TRL of 9, that means it's a proven product ready to go on a store shelf.
So, what's a moonshot look like in this world? Well, take something called tetratonite. It's a material that was first discovered in meteorites. I'm not kidding. Scientists are now trying to grow it in a lab. It could be insanely powerful, but it's a very, very low TRL. And this is the classic dilemma. The most powerful, game-changing solutions are often the farthest from being real. And the practical fix? Well, a great example is a magnetless motor. Some car companies are already using them in their EVs. They have a high TRL. They're literally on the road right now. But here's the catch. They work great for some things, but they just can't replace those super powerful REPMs in every single application. It's always a trade-off. Okay, so you've got these 2 big paths, the moonshots and the practical fixes. How does a country like the UK decide where to place its bets in this high-stakes global race? Well, it turns out the UK's big strength is in redesigning technology. Its car industry is a world leader in developing those practical, high TRL solutions, like the rare earth-free motors we just talked about. They are focused on what works now. But here's the flip side. The UK's weakness is in new materials, the moonshots. The country has absolutely brilliant people in its universities, but it really struggles to take those amazing lab discoveries and turn them into something a factory can actually produce. Which, begs the question, why? Why is it so incredibly hard to get from a great idea in a lab to a real product on the market? This quote from an Innovate UK report just hits the nail on the head. It says, a distinct lack of funding that bridges the gap between seed rounds and commercialization has been identified. Basically, it's not a shortage of good ideas, it's a shortage of the cash you need to scale those ideas up.
And this is what people in the industry call the funding valley of death. Look, there's plenty of money for brand new early stage ideas. And of course, there's money for products that are already successful. But that critical middle part, the commercialization stage, where you try to scale up, that's the valley where funding dries up and great ideas go to die.
And hey, it's not just about the money. You've also got big companies who are hesitant to work with small, scrappy innovators. The UK doesn't really have its own domestic magnet supply chain to begin with. And on top of all that, everyone is super cautious about sharing their data and protecting their intellectual property. It's a whole mess of challenges. Okay, so that's the problem. It's a complicated picture. So what's the game plan? How do you actually solve this and win the race?
Well, the report lays out a pretty clear three-part game plan. First, you have to increase the funding that's aimed specifically at that valley of death we talked about. Second, centralize the research. Create a single, dedicated research hub for these magnet alternatives. And third, you have to foster collaboration. Get an industry group going that gets the innovators, the academics, and the big corporations all in the same room talking to each other. Because at the end of the day, this whole race isn't just about building a better magnet. It's about securing the technologies we absolutely have to build a sustainable future. I mean, the stakes really couldn't be any higher.
And all of this leaves us with one big final question. As the entire world scrambles and races toward net zero, which countries are going to be the ones that innovate fast enough to actually build that future?